All right, taking a look at number 19 of our Honors Chem Semester 2 Final Exam Review. If we have 100 grams, how would you make 100 grams of a 10% sugar solution? So the percent always refers to the solute. So our solute in this case is sugar. So I would need 10 grams of sugar. And we would then need 90 grams of a solvent, which is typically water, to make 100 grams of the solution. All right. What is the solute in the solvent when salt dissolves in water? The solute, kind of similar to our question there, is salt, and our solvent is water. We specify it there. All right. For our next several structures here, we want to be able to answer questions about how the electrons are being shared, which element has the stronger pull, and be able to draw any charges and things like that. So we want to remember for this one is our electronegativity trend. So kind of draw like a little mini periodic table here. The trend is that when you go up and to the right, the electronegativity increases. So as you go from left to right and bottom to top, the electronegativity increases. All right. So for 21, both of these are, so you have two nitrogens bonded. And so what they're going to be doing is that we're going to be equally sharing the electrons. And they both have their same electronegativity, same strength, or pull on the electrons, so they're going to be sharing the electrons equally. For the which element has a stronger pull, I would say you could say either none or you could say nitrogen. Both would probably be correct. For this one, we would have no charges present because the electrons are being equally shared. If you have no charges, that means that it's going to be a non-polar molecule. All right. One thing to note on this one, this is actually technically a triple bond, but I didn't want to introduce something that was kind of new. But it really wouldn't change anything about anything that we mentioned so far. For our next example, LiCl. So lithium is kind of over here on the left and chlorine is on the right. We're actually dealing with a metal and a non-metal. So that's actually the first thing that I would tend to notice there. And so we could automatically classify this as being ionic, lithium being a metal, chlorine being a non-metal. So in an ionic substance, you have transfer of electrons. Okay. Which element has a stronger pull? It's always going to be the non-metal, which is chlorine. Adding charges here. I would have a positive charge, full positive on the lithium. It loses an electron permanently, and chlorine gains it permanently. So it has it sort of all the time. All right. For our next one, this is Co2 carbon dioxide. We have within like this bond here and this bond here, they're both the same bond. We're going to be looking at those. So between the carbon and oxygen. Oxygen happens to be, so these are two different elements, but we're not dealing with the metal and non-metal. So what we have is an unequal sharing of electrons. So then we need to recognize the trend and look at the trend and where these two elements are in the periodic table. Oxygen happens to be further to the right. So oxygen is more electronegative. So that's the element with the stronger pull. Adding any charges here, so if oxygen has a stronger pull, it's going to get a partial negative charge, partial positive on the carbon. The carbon-oxygen bond on the right-hand side of the molecule is the same, so I can add a partial negative there as well. For letter D, classified as being polar, nonpolar, or ionic. So in this molecule, this one is going to be nonpolar. So we can think about lines of symmetry. There's two. also kind of on the outsides of the molecule, it's all the same charge. All right, so that's no poles, non-polar. For our next one, the bottom left here, thinking about like one of these carbon to chlorine bonds. So we're dealing with two nonmetals, but they're not the same. So we have an unequal sharing of electrons. Which one is further to the right on our periodic table? Chlorine. Then adding any charges, I would put partial negatives on all of our chlorine since it has a greater electronegativity. It's going to add the electrons more of the time. And then for part D, classify this non-polar. So no poles, there's no symmetry, or actually there's two lines of symmetry, but the left side looks negative, right side is negative, the top and the bottom are negative. So all around, it's the same charge, so therefore there are no poles or not, and so it's non-polar. Our next one, we've got two different types of bonds. We have the carbon-hydrogen and the carbon-chlorine bonds. We can put a partial negative on our carbon to chlorine, just like we talked about in the other one. So between the carbon and chlorine and the carbon and hydrogen, these are both unequally sharing electrons. So they're all nonmetals, so they're sharing the electrons, but they're not sharing them equally. Between the carbon and the chlorine bond, the chlorine has the greater electronegativity. Between the carbon and the hydrogen bond, however, carbon has the greater electronegativity. So what that means is that between the carbon hydrogens, carbon is more negative, hydrogen is more positive. So I'm actually going to put a partial positive on the hydrogens. So what that means as far as our classification, well, the top and the bottom are both positive, but the left and the right, positive and negative. So there's a pole from sort of on the left and the right-hand side. So I'm going to call this a polar molecule. All right. Last one, we've got SO3. So again, nonmetals are involved in these bonds. And so we're unequally sharing. They're nonmetals, but they're not the same nonmetal. When it comes to the bond, oxygen, they're both in the same family. Whoops. They're both in the same family, but oxygen is higher up on our periodic table. So oxygen is more electronegative. So that means that we're going to put partial negatives on the oxygens. And in terms of the polarity, all around the outside, it's all negative. You might be able to see the three lines of symmetry. We have lines of symmetry this way, and this way. But the main idea is that all of these around are negative, so there's no poles. Therefore, this is non-polar. All right. For our next page there, we're going to be looking at some heat calculations, and thanks for watching.